Hey guys, let's discuss this interesting system of nonlinear equations. The most basic solution we can imagine is substitution. Let's write y as a quadratic function of x and substitute it into the other equation, which can be rearranged into a quadratic equation of x. We can decrease the order by factorization, which does need some experience and inspiration in this particular case. There are two possibilities where either of these two factors can be equal to 0 and y can be rewritten as a linear function of x. Remember that x is not equal to y. So let's eliminate this possibility and keep the other one. We can solve for x by the quadratic formula and y by substitution. We have two sets of solutions with x and y switching between two values. And based on the formats of these two expressions, substitution of either set will give us the same result, which can be verified in our calculation by the sum of squares in the numerator and the difference of squares in the denominator. This solution is straightforward, although it does take some time. And you may ask, is it possible to escape from this solution? Well, the answer is yes. And you may say, because x and y are the two roots of the equation we have already derived in the previous slide, we can apply Vieta's formula for a quadratic equation to solve for the product and the sum of those two roots using the coefficients. Well, that's a partial escape where we avoid solving for x and y explicitly. But still, we have formulated the system of nonlinear equations related to x and y explicitly. Let's do a total escape by avoiding them both. Watch the format of this expression. Both the numerator, the sum of squares of x and y, and the denominator, the product of x and y, involve x and y at the same time without increasing the order based on the original system of nonlinear equations. And we can formulate another system of nonlinear equations by addition and subtraction and rearrange them. Since x is not equal to y. So x minus y is not 0. Let's divide x minus y on both sides and apply the identity for the difference of squares to this term to get the sum of x and y and the sum of squares of x and y by substitution. To get the product of x and y for this equation, we can take the square of both sides, expand it, substitute the sum of squares of x and y into it, rearrange it, and reduce the coefficient to 1. Now that we have the numerator, the sum of squares of x and y, and the denominator, the product of x and y, we reach the same result as in the previous solution. Alright guys, that's the end. Thanks for your attention. I'll see you next time.